Again, what this is showing is molar quantities are a quantity that we can actually manipulate and see, whereas we can't see an atom. All right, so you're going to have problems like this on your quiz, your homework, your test. They say calculate the number of moles of carbon in 0.0265 grams of pencil lead. So you know this is about the amount of lead when you're writing on your paper with pencil that's deposited on the paper. So you write down what's given. You write down what you're trying to find, the moles of carbon. You come up with a conceptual plan. We need to convert grams to moles. So, how do we do that? Well, we need to know the relationship between grams and moles. Well, we look at the periodic table. For every 1 mole of carbon, we have a mass of 12.01 grams. That's straight from the periodic table. There's our equality, and from that equality, we make a conversion factor. So we want to get rid of grams. So with the grams in the numerator and moles in the denominator, grams in the denominator and moles in the numerator, so the grams will cancel out. And so we divide both sides of our equality by 12.01 grams. This side becomes 1. That tells me this is a true conversion factor, and that's what we placed here. This has 3 significant figures, so we should have 3 significant figures in our final answer. This quantity of carbon is less than 1 mole, so we would expect this answer to be less than 1 mole. So that's how we would check the answer. All right, so there's their conversion factor we talked about. Grams cancel out, and we're left with moles. All right, let's try another problem. This one's reversed. Calculate the moles of sulfur in 57.8 grams of sulfur. Well, it's actually the same type of problem. So we write down what's given, 57.8 grams of sulfur. We are trying to find the moles of sulfur. The conceptual plan is to convert grams of sulfur to moles of sulfur. We look at the periodic table and we find that 1 mole of sulfur is 32.07 grams. We use that equality to make this conversion factor, and we want the grams in the denominator, so they will cancel out and leave us with moles of sulfur. That's what it would look like. This has 3 significant figures. You should have 3 significant figures in your final answer. This quantity is larger than a mole. A mole is 32.07 grams for sulfur. We've got more than that. We've almost got 2 moles, and so this answer is pretty close to 2. And that's how you would check. All right, so this one's a little bit more difficult. We need to convert how many copper atoms are in a penny weighing 3.10 grams. So what's different about this problem is we got to convert the grams to moles, and once we get moles, we know the relationship between moles and Avogadro's number to actually find out how many atoms of copper we have. So we're going to have 2 conversion factors in this problem. So write down what's given. Write down what you're trying to find. Come up with your plan of action. It's grams of copper given. We got to convert that to moles because we don't know the relationship between grams and atoms, but we do know the relationship between grams and moles. That's molar mass. So molar mass is here. And then once we know the moles of copper, we can use Avogadro's number to convert moles to atoms. So that's what we know. The first one you find on the periodic table, you don't memorize that. You do need to memorize the second equality here. 1 mole equals Avogadro's number. There's our conversion factors. Again, what drives the conversion factor is you know the relationship. You need the grams in the denominator, so the grams cancel out. You need moles here to cancel out with moles here, and that leaves you with atoms, and that's what we're trying to find. Here it is, calculated out. We should have 3 significant figures in our final answer, and we do. Grams cancel out, moles cancel out, and we're left with atoms. All right, one more problem. How many aluminum atoms are in a can weighing 16.2 grams? Write down what's given. Write what you're trying to find. Come up with your plan of action. We got to convert grams to moles. We use molar mass to do that, and then we convert moles to atoms using Avogadro's number. We get this relationship off the periodic table. You memorize this one, and then you go and make your conversion factors. There it is written out. Grams cancel out, moles cancel out, and you're left with atoms of aluminum.